Hi, I want to just move on to another topic in this video, and we'll be looking at what is called filtering. And the basic idea of filtering is that when we are recording signals, there are unwanted components in that signal that we want to remove. These unwanted components are called noise, and the noise doesn't contribute to uh, to what we want to do with the signal, right? So, for example, if you're recording ECG and you want to find out the heart rate, and there is just a lot of some interference that is preventing you from seeing the peaks of the ECG clearly. So that interfering signal is the noise. Okay, so what I want to do in this particular video is look at noise and just very briefly, in a very general way, talk about what kinds of signals might interfere with our signal, what kind of things would interfere with our signal. Okay, so there are, of course, various kinds of noise. So let's assume that we have a, let me just get my cursor on here. So let's say we have a sine wave, and that's our original signal. So you could have various kinds of distortions in the signal, right? So you could have a distortion like this, where you have the signal level moving up or down, and this kind of a noise is called the drift. Instead of having a drift, you could have a constant addition to a signal, and that is called an offset noise. You can have a, a signal which is of a higher frequency. Let's say it's also a sine wave, but of a higher frequency, adding on to the signal that you really want. And so the signal that you really want is this one, the overall shape of the signal. But you have these sharp changes here. And let's say these sharp changes are predictable. Okay, let's say they are the 50 hertz noise from the mains. So then you have interference. If this added signal is random and comes because of some kind of process, and we'll talk about what those processes are in medical instrumentation too. So those would be some kind of a random noise. Okay, so you can have all these kinds of noise, and now the question is, how will we remove these noise from the signal? So, for example, how would you remove the noise from this signal? So the original signal is this, and you have added one to the signal, and it's gone up, right? There is an offset. So how can you remove that? Fairly straightforward, right? You just subtract that offset from the signal, and you get the original signal. So you've removed the offset from the signal, right? So there are some simple ways of doing it. Now, take for example this signal here. How would you remove noise from here? Now, this signal comprises of two parts. One is this sinusoid that you want to keep, and then there is this random fluctuation that you want to remove from the signal, right? One of the ways to remove that would be to just take a small window here and average the signal out. If you average the signal, you hope that the sine wave is not cancelled, but the random wave, because random means it goes positive and negative at the same rate, it could cancel out, right? So that kind of filter is called a moving average filter, which I've shown here. So here's your noisy signal. You take a small window here, you average all the points here and put it at that place. Then you move the window one step ahead, and then you again do the averaging and place the point one step after that. And once you do all this processing, you get a cleaner signal. Now, this is not very good, but it's much better than this one, right? So that's called a moving average filter. So there are these various ways of doing filtering. But what we want to do in this course is focus on one way of doing filtering, and that is called frequency filtering, which we'll discuss in the next video.